Have you ever wondered how to organize and manipulate a large set of data in Python? In today's digital age, handling big data is crucial, and Python provides an efficient way to do so. Python lists. These handy tools are significant in Python, allowing us to store, access, and modify data swiftly and efficiently. They are the building blocks to understanding data structure in Python. So, are you ready to dive into the world of Python lists? Buckle up, because you're about to master it. A Python list is one of the most versatile data types Python offers. Imagine you're a librarian, and you're tasked with organizing different types of books. You've got novels, biographies, textbooks, comic books, and more. Now, wouldn't it be great if you had a flexible system to arrange these books by their type, author, or even by the color of their covers? Well, in the world of Python, such a system exists, and it's called a Python list. A Python list is like a flexible library shelf that can hold different types of data all at once. It can store integers, floating point numbers, strings, and even other lists. It's like a container that holds a collection of items, and these items can be as diverse as the books in our library analogy. The beauty of Python lists lies in its versatile nature. You can create a list with a single type of data, like a list of integers, or you can mix and match different data types. For instance, you can have a list that contains a number, a string, and another list. It's like having a library shelf that can hold a romance novel, a chemistry textbook, and a box of comic books all at once. But how do Python lists work? Well, each item in a list is assigned a unique number called an index. This index works like a label on a library book, helping you locate and access the item quickly. The indexing in Python lists starts at 0, not 1, which may seem odd at first, but you'll get used to it as you dive deeper into Python. Now, you might be wondering, why use Python lists? What's so special about them? The answer lies in their flexibility and simplicity. They allow you to store, access, modify, and manipulate data in a simple and intuitive way. You can add items, remove items, sort items, and much more with just a few lines of code. In essence, Python lists are your go-to for organizing and manipulating different types of data. Creating a Python list is as simple as putting different comma-separated values between square brackets. Now, let's dive in. To create a list, all you need to do is enclose your comma-separated items in square brackets. For instance, a list of integers could be, while a list of strings could be. You can even have a list of floats, like. Python isn't picky, and you can mix and match data types in a single list. So, a list containing an integer, a string, and a float, such as, is perfectly valid. It's all about what works best for your project. Just remember, each item in the list is an element, and they're all separated by commas. And there you have it. You've just created your first Python list. Accessing elements in a Python list is straightforward. You just need to know the index of the element. Let's say we have a Python list of delicious fruits. We've got apples, bananas, cherries, and dates. Now, if we want the first fruit on our list, which is an apple, we simply use its index. In Python, indexing starts at 0, so to get the apple, we type the name of our list followed by the index of the apple in square brackets, which is 0. But what if we want the cherries, which are third on our list? The process is the same. We just use the index 2 instead of 0, because remember, indexing starts at 0. Now let's talk about negative indexing. Python has a neat feature where you can use negative numbers as indices. This starts from the end of the list. So, if we want to access the last fruit on our list, which is dates, we can use the index -1. But what if we want a slice of our list? Let's say we would like to make a fruit salad with bananas and cherries. We can use slicing to get these two fruits. Slicing in Python works by specifying two indices, separated by a colon. The first index is where the slice starts, and the second index is where it ends. But be careful, the end index is not included in the slice. So, for our fruit salad, we start at index 1, the bananas, and end at index 3, one step past the cherries. So, that's how you access elements in a Python list. Whether you want a single fruit, a range of fruits, or even the last fruit on your list, Python's indexing and slicing features make it easy. With these skills, you can easily access any element in your Python list. Python lists are mutable, which means you can change their elements. Now let's dive into the world of modifying and manipulating these flexible data structures. Imagine you have a list of your favorite movies, but you just watched a fantastic new one and want to add it to your list. Python makes it super simple with the append method. Just call this method on your list and pass the new movie as an argument. Voila, it's added at the end of your list. But what if you have another list of films you've been recommended and you want to add them all to your favorites? That's where the extend method comes in handy. Again, call this method on your list, but this time pass the entire other list as an argument. It's like merging two roads into one. Now let's say you've rewatched a movie on your list and it's not as great as you remembered. Python can help you here too. Use the remove method, pass the movie title as an argument, and it will disappear from your list, just like magic. But what if you want to remove a film, but also keep a record of it, maybe for a watch again later list? Python has you covered with the pop method. Call pop with the index of the movie you want to remove. The movie will leave your favorites list, but the pop method also returns the removed element, so you can store it for later. Sometimes you might want to change an existing movie title in your list, perhaps because you've noticed a typo. No problem. Just use the index of the movie and assign the corrected title to that index. Python will replace the old title with your corrected one. Remember, these methods are not exclusive to lists of movies. They can be used with any Python list, whether it's strings, numbers, or even other lists. Now, you've learned how to modify and manipulate your Python list to suit your needs. With these methods in your Python toolkit, you can become a master of list manipulation in no time. To efficiently work with all elements in a Python list, you can use a loop. Now, what is a loop? In simple terms, a loop is a programming concept that allows us to repeat a block of code as long as a certain condition is met. Let's take a look at how we can loop through a Python list. The most common way to do this is using a for loop. A for loop allows us to iterate over each item in our list, one at a time. Here's how it works. We start with the keyword for, followed by a variable name of our choice, then the word in, and finally, our list. For instance, if we have a list of fruits, our loop could look like this, for fruit in fruits. This would allow us to perform actions on each fruit in our list, such as printing them out or modifying them. Keep in mind that Python's indentation rules apply, so all the code inside the loop must be indented. So there you have it. With loops, you can easily handle all elements in your Python list, no matter how large it is. Let's sum up everything we've learned about Python lists. Python lists, in the simplest terms, are a collection of items that are ordered and changeable. They allow duplicates, making them a versatile tool in any coder's toolbox. You can store a series of items, whether they are integers, strings, or even other lists, all in one place. Creating a Python list is as easy as assigning items to a variable within square brackets. For example, my underscore list =. It's as simple as that. Accessing elements in a Python list is done by referring to the index number. Remember, Python counts from 0, so at my underscore list will give you apple from the example list. Modifying Python lists is just as straightforward. You can change, add, or remove elements using various methods. To change an element, you can use the index number. To add an element, you can use the append or insert method. And to remove an element, you can use the remove, pop, or del keyword. Looping through a Python list allows you to perform actions on each item in the list. Whether you need to print each item or apply a function, the for loop is your go-to tool. And that's a wrap on Python lists. With these